The cluster is running, but every node is not ready because no network plugin is installed. The exam gives you a Flannel manifest and asks you to install and configure a CNI. Let's apply it, watch it fail, find out why, and fix it. Here is the setup. A fresh cluster has no CNI, so its nodes are not ready and CoreDNS is stuck pending. You are handed a Flannel manifest and told to install a network plugin of your choice. The catch, which you only discover after applying, is that the manifest's network does not match the cluster's pod-CIDR. A CNI plugin is what gives pods IP addresses and wires up pod-to-pod routing. Without one, the kubelet reports the node not ready. Flannel runs as a DaemonSet, one pod per node, and reads its settings from a ConfigMap called kube-flannel-cfg. The important field is net-conf.json network, the address space Flannel hands out. Because Flannel runs with kube-subnet-mgr, it also reads each node's assigned pod-CIDR, and it refuses to start if that pod-CIDR is not inside its configured network. Start by confirming the starting state. Every node is not ready, the classic symptom of a missing CNI. And in Kube's system, CoreDNS is pending because it has no pod network to join yet. Everything else the control plane needs is up, so this really is just the network plugin that's missing. Now install Flannel by applying the manifest. It creates the kube-flannel namespace, the ConfigMap, and the DaemonSet. But when you look at the pods a few seconds later, they are not running. They're in CrashLoop backoff, or error. Applying the manifest was necessary, but on this cluster, it is not sufficient. Don't guess, read the logs. The Flannel pod says it failed to acquire a lease because the node's pod subnet, a slice of 192.168.0.0.16, is not inside the Flannel net configuration of 10.244.0.0/16. That's the whole problem in one line. The manifest ships a default network that does not match how this cluster was built. The cluster's pod-CIDR is authoritative, so Flannel is the thing that has to change. Fix it in the ConfigMap. kubectl edit opens the live kube-flannel-cfg object in VI. Inside net-conf.json, network is set to 10.244.0.0.16, the manifest's default. Change it to 192.168.0.0.16 so it matches the cluster's pod-CIDR, then save and quit. kubectl pushes the edit back to the API server the moment you write the file. Nothing else in the ConfigMap changes. A ConfigMap change does not restart pods on its own, so the Flannel pods keep crashing on the old config until you cycle them. Delete the Flannel pods, and the DaemonSet recreates them, this time reading the corrected network. Now they come up running, and within a few seconds, the nodes flip to ready and CoreDNS schedules. The CNI is installed and configured. Finish by proving it actually networks, not just that the pods are green. Create 2 pods on different nodes and list them wide. Each has an IP from 192.168.0.0/16 on a different host. Ping one from the other, and the packets ride the vxlan overlay between nodes. Replies come back, so the CNI is doing its job, end to end. A few traps. Not ready nodes plus pending CoreDNS almost always means no CNI, so install one first. After you apply a CNI, always check its pods are actually running. Don't assume the apply worked. When Flannel logs failed to acquire a lease, that is a pod-CIDR versus network mismatch. Make Flannel's network match the cluster, since the cluster CIDR is fixed. And remember, a ConfigMap edit needs a pod restart to take effect. To recap, no CNI means not ready nodes. Install Flannel, and if it CrashLoops, read the logs. A lease failure means its network does not match the cluster pod-CIDR, so fix net-conf.json in the ConfigMap. Restart the pods, and the nodes go ready. Then prove pod-to-pod connectivity. Subscribe, and the full write-up is on dev.to.